Good morning and welcome to this second European technical webinar of the COWI project. My name is Gabriele Pesce and I will moderate today's event. For those who don't know me, I work for Euroheat and Power, the European Association of District Heating and Network, and in particular for the DAC Plus technology platform, the research and innovation branch of Euroheat and Power. I'm very glad to see such a technical and professional audience today because we will speak about a very important topic, the transition from a traditional standard district heating network to an ultra-low and low temperature one. So I won't explain the benefits of the reduction of the temperature because I'm sure that you know much more than me. Suffice to say that lowering the temperature entails a series of issues and matters that can differ from one pilot to another. Today, the main goal is to debate on the presented solution and to get feedback from the scientific and technical community. So I really encourage you to pose questions. Don't be shy. Also, a very technical question. Our experts are here for you. So before starting, few technicalities. So the webinar will be recorded and published on the Euroheat and Power YouTube channel and available on the COWI website. To pose question, you can use the question box on GoToWebinar. So audience is mute as default, so you can speak. You cannot speak, but of course you can write your question on the dedicated box. So I will pose your question to the panelist. If you have any technical problem, you can use instead the chat function. So let me now briefly introduce our panelist. I kindly ask you to switch on your webcam if you want. So today we will have, so I cannot see, maybe the panelist can switch on the webcam. But we can see. Okay. Okay. So Steen Olesen, project manager in COWI, Emanuele Zilio, a sustainable energy engineer always at COWI, and Sarah Kralmark, project manager in business development at Kraftingen, and of course myself as moderator. So before leaving the floor to the our expert, I would like to briefly introduce ULTDH project. So basically, I would say that ULTDH is the one of the most innovative projects in which we are partner. I'd say that it's not exaggerated to say that we are already at the 5th generation. We are talking about 5th generation district heating. And we are already in the future with a share of renewable, at least in one of the demo sites, of 100%. From a formal point of view, ULTDH is a Danish-Swedish collaboration, and it's a Horizon 2020 project. So the main focus of the project is the development of innovative solutions for the use of very low-grade surplus heat for ultra-low temperature district heating network. The project presents 2 demo sites, but I have to say that even the small number of demo sites, he has a lot of remarkable facts. In the Swedish demo, we are talking about the largest low temperature district heating network in the world, and it's already operating, and it's totally decarbonized. The second demo case, and that will be the focus of today's webinar, is in Høje-Taastrup, Østerby, in a suburb of Copenhagen, and he has, for example, the largest PV installation rooftop of Scandinavia. So let's just present very quickly the 2 demo sites. The Brunsøy area, it's a suburb, it's in the let's say back street of Lund. There is this science village area that is being built, covering 18 hectares of land, right between these two scientific research institutes. The MAX4 is a particle accelerator, and the ESS facility. The plan is to build approximately 250,000 square meters of gross floor area, providing space for business, educational facilities, and research in the field of innovation and cutting-edge material research. The production in Lund is already fossil-free. Expansion of the city will call for more non-fossil energy sources to be integrated and utilized in the system, such as low-grade waste heat. Adding more biomass wasn't an option in the long term, as it's a scarce resource and can be used better in other places. The main source of low-grade heat will be recycled from fossil-free waste heat from the ES research facility. The total, sorry, I can show you better. The total cooling demand for the ESS is 29 megawatts. The waste heat will supply the new low-temperature district heating network, and the residual waste heat will be delivered to the existing district heating system in Lund. The low-grade heat sources from cooling water at the MAX4, so the particle accelerator, is 6 megawatts and is already available for exploitation. The total available source of low-grade heat, including the ESS, will grow to 250 gigawatts per year by 2025, with a maximum capacity of 40 megawatts. In order to utilize the low-grade surplus heat, normally lost as cooling in a cooling tower, it is necessary to develop and install an innovative heat exchanger coupling in order to supply low-temperature district heating for the low-temperature district heating in the COWI project. So let's see. The second demo site is being built in Høje-Taastrup in the greater Copenhagen area, about 20 kilometers west of the city center of Copenhagen. The district heating supply in Høje-Taastrup is getting greener and greener every year. In this case, the surplus heat will be harvested from various sources. And for example, the city mall called City 2 shopping mall, the data center of the Danske Bank, the Danish bank, and the DSB, the Danish railroad facilities, but also hotel and other municipal building and facility. In particular, the surplus heat derives from the cooling machine at the City 2 mall that will operate on power from more than 16,000 square meter PV plant with an installed capacity of 2 megawatts. So, as I already said, is the largest PV installation in all the Nordic countries. And the other source of surplus heat will be the cooling machine and cooling of servers at the Danske Bank Center and hotels, having a high cooling demand all year round. The two demo cases are different, and of course the envisaged solution are of course different. Today we will focus in particular on the Østerby case, that it's the let's say the more traditional one. But Sarah, for example, will present some analysis on business model that should be applied in the Brunsløy area. So I already talked too much, so I kindly ask the first expert, Stan, to present his work. So please, Stan, you can switch on your webcam and share your screen. Thank you.
Yeah. Thank you. Can you hear me?
I can hear you. I can see your presentation.
Okay. That's good. Thank you very much for the introduction, and I'm very happy to be able to present this case because it has actually been something I have focused on preparing this area to convert to low temperature district heating for years, and I'm happy to say that we are in the stage where we have finalized all the implementation, and they are getting ready to get excess heat from the CT2 shopping mall, but already they are supplied with low temperature district heating. And another very important part of the project COWI is, of course, to share knowledge, to present what we have done in this session here, but also to make sure that their experiences are spread physically, implemented in other areas. And there is a huge potential to prepare existing housing stocks for the low temperature district heating. And we are 30 kilometers away from Østerby. The second area will be prepared. We just shipped a proposal to implement a similar sized demo project based on the Østerby case. So we are definitely getting the knowledge spread from Østerby because it can be used. It is very important. You introduced the area where we are. It's a municipality that has quite ambitious reduction targets. That's why the municipality of Høje-Taastrup, they has sort of activated the project in the area, and they are keen on getting the job done in other areas of the municipality as well. The objectives, you introduced it briefly. I have to remove this. Is to create a complete sustainable town development and connect it also to a city development area just on the other side of the CT2 shopping mall. There's a bare field now, and the town is developing a new town to make a complete, remarkable Danish showcase. We implement all types of ICT-based control systems to sort of dynamically optimize the balance between use of renewable from the CT2 PV installation. When are we gonna use the heat pump, and what's the balance? So there's also a test of new sort of what are they called, valve systems, so that we can easily mix in higher grade district heating into the low temperature district heating network. And that is a complete system where we can have all elements that we have developed on showcased. This is the customers in the area. There's quite some numbers. It's 36,000 square meters of building stocks, all from the 80s. We have focused on the 158 terraced houses in the area, Eskov, then towards 1, 2, and 3, which is different types of housing associations, and then a large social housing company in the middle. That's the yellow one, TAB Østerby, and also a kindergarten, a public kindergarten. The existing system is at least 35 years old, and there was a lot of heat losses in the ground, and a complex setup of where they bought sort of their heat from themselves. You could say that they were one big customers towards the district heating company, but then they split the bill between them and shared the losses and stuff, so on. Why is that important? That's important because they were kind of interlocked into an old system where they were not really motivated to renew their system, and that's where the COWI system came handy and could sort of make it easier to support them in the decision process. That's what I said. They had one heating association. They were responsible towards the utility company, maintenance of the heating station, and they had these 6 groups of customers where they shared the bill towards 1 and 2 and the 6 different customer groups, and these customer groups, they were divided into different organizational setups, so that they had to pay for their internal heat losses. And yeah, well, a long story short, it took a huge amount of time to sort of convince these different customer groups whether it would be a good idea to go into the process or not. So we prepared a detailed action plan to answer all the necessary questions, and arranged that in an iterative process between the partners, as you see, and decided how to go forward. So it built it actually on a, you could say, on a first attempt, that where the district heating company didn't succeed. That was already in 2010, where the district heating company tried to convince the different user groups with a traditional setup, where they wanted to sort of just give them a simple offer and for a traditional renewal of the whole system, and it didn't work. The district heating association, they didn't accept. They couldn't find find it attractive, because what counts in the end is, of course, the local business case for the different eyes that looks on the case. So the second phase was when we got this EU support to try to convince them again, and we presented it during a number of presentations, and I will go through the decision process, because I think it can inspire you wherever you are in Europe to sort of look into the numbers. Be prepared to have detailed calculations both on micro and macro economy level, meaning that the flat owner, or the one renting a flat in the one corner of the area, should be able to see themselves exactly down on the micro economy. What will I need to pay upfront? How much can I save on the upfront cost? Will there be some possibilities? And that was what came really handy during this process, that we were extremely careful on doing all the numbers before we met up with the people in the different groups to take the meetings. The first step was to prepare and motivate the heating association on the both macro and micro level economy, and describing what would be the benefits going from the existing network to the new low temperature district heating network, and what would the risks be. And the outcome from that step, that was in December 17 actually, that they were interested. They could see the benefit of getting having a possible EU funding to sort of ease the process. And there was the first Q&A session with the board. The next step was to meet with the tenants, just informal, explaining them what is the nowadays situation. You have a 35% heat loss. It's hidden somewhere on the bill. You don't see it. What could the benefit be if you go on this project? Yeah, well, you could go down to 11% heat loss and benefit of both yourself and the environment. And that was interesting for all the different groups. They could see that, well, it's probably a good idea to go forward on that. So we presented the initial economy and the environmental beneficial stuff for the tenants, and they were interested on all you could say, all parts of what we presented, both economy and the process. They could see the urgency of their old district heating system maybe breaking down and costing them more and more over the coming years, and then also the environmental beneficial stuff in this project. In the end, it turned out that of course the economy won over the environment. So there was a little, you could say, we didn't convince the social housing company in this phase. They are working separately, but we have the 159 stakeholders. They have now been converted and are happy. So step two, we after the principal decision where they said yes for the project, we presented the lean solution, as you see below, where the district heating company HDF, they are responsible directly down to the final user in each of the individual 159 flats, instead of the complex organization above. So that was the yes they gave us. And then we spent from February 18, and then you see all the gray dots on top. I'll go through them steps until we had the final yes, and we could start the implementation in 19. So we got the acceptance from the board. Applied the next level decision triggers, and again went through a number of meetings. You probably know how it is that we needed to drink a lot of coffee and talk with them in smaller groups, having Q&A sessions, and supporting them in the process of saying yes, we think this is a good idea. So we had 2 rounds with them in this third step. Presented it again, necessary, and the output, you could say the learning here is it is really necessary to be precise to make the tenants comfortable with the decision. An example, on a meeting there was a question: will you plant my new henge again? Will you plant a new henge again? Will you leave the lawn very nicely? And the answer was from the district heating company: no, we are gonna just mess it all up and we will just leave it like that. It was of course meant as a joke, but it shocked the whole process, and we needed to spend really a long time to get it back on track again. So I mean, you have to be sure that everyone on board and on the support in the decision process and have the right attitude and know what will concern the end user and maybe make them reluctant on saying yes and sign the contract. Step 4 was the final meeting in the end of May 18, where we presented for the Varmelag, the heating association, that everyone would say yes with the final condition, and that was a success. Again, they said yes, we are ready, and the outcome was planning for the test installation, but because now we needed to dig in and show them in reality, and we prepared, the district heating company prepared 2 test installations so they can see what will the change be, and that's what Emanuele will present later on. How does the installation, the units look, and how does they differ from the installation they had in case. And there we left it from COWI and just supported the district heating company in the final preparation and the signature of contracts so that they could start preparing the installation phase. And that's exactly what we have here in August. We had a last meeting, and why do I say all this? Why is it necessary to go through these steps? I think it's because I've seen so many times that also, if we go back to the 2010 situation where the district heating company just planted a number of contracts on the board, on the table, and for every tenant, and they ask, are you interested in having a new system? We pay, and you just pay us, and we do the job, and they turned it down. No, they need to have a really clear explanation and a very good overview on the macro and micro economy to actually let it go, and that's why we in August 18 decided to keep the partners updated, all the different user groups in the area, and that's what I think the district heating company Høje-Taastrup has also learned a lot on this route with this project, that it's really important to keep people updated. And then you could say the real stuff, I have summed it up in the 2 last dots. The implementation started in 19 and was completed during the spring, I think, or was it actually spring this year? And now the monitoring process has started. We have implemented indoor climate sensors in 20 of the flats, and also we are monitoring data from every installation to show that do we see what we expect from the installation. One thing is for sure, they are not low on heat and domestic hot water, so I guess they are happy so far. That was my presentation. I think I will leave it here because the rest is just, yeah, well, you could say the rest is just to sum up. I think it's very important to be careful, prepare for thorough stakeholder analysis, identify the potential risks on the route, design an attractive decision trigger so that you know for sure that you will have a plan B if something goes wrong in the process. Know your numbers, be prepared, go really high on the detail level before you start talking with the stakeholders, and then spend enough time. And enough time in this case was a huge amount of coffee drinking and a lot of evenings trying to sort of make the final yes. And I'm kind of sort of very you know, environmental. I'm aware that this is important, but in the end, people let the numbers count. So it only counts for some time, and then people start to look on the money. That's it, I think. Yeah, thank you for listening.
Thank you, Stan. So it's very interesting, your presentation. I think it's one of the most important takeaway is that we can have the most advanced and skyrocket science for a lower the temperature, but if we don't engage very well the stakeholders and the final consumers, you can drink as much coffee as you want, but you know, that hinder a lot. I just remind the audience, if they want to post question, they can write their question on the dedicated question box. We will dedicate a question time at the end of the pre-presentation. So I will very quickly leave the floor to Emanuele. Thank you, Stan.
Yes.
So Emanuele, if you want to share your presentation, please.
Going to move it. Yes. Okay.
Perfect. We can see.
Yes. Good. So my name is Emanuele. I'm going to introduce to you the substation that we considered in our COWI project in order to meet the requirements for low temperature district heating. What I'm going to talk about are basically the substation that are possible to implement in apartments or single family houses. There are many names that can be named. Basically, they are known as district heating unit, individual substation, or individual heat exchanger, flat station, or heat interface unit. It basically depends on the producer. There are two types of substation. There is one with a single heat exchanger. Basically, the heat exchanger is used to produce domestic hot water, while the water coming from the heat supply goes directly through the space heating system of the building. The second one is it has two heat exchangers. Basically, both the space heating system and the domestic hot water system are interfaced from the heat supply. We used both of the solution in our COWI project. The one with one heat exchanger, we use them in Sweden, and with a supply temperature of 60 degrees. while the second one with 2 heat exchangers, we used it in the case in Denmark with 55 degrees temperature supply. These are the type of installation that are usually implemented. The first one is in a traditional district heating system, where there is a substation and usually a water tank on the secondary side, and this require a high temperature supply because of Legionella problem. And usually this solution has a water circulation pipe that has heat losses inside the building. The other two solutions consider the implementation of substation in the apartments, like in this, for example, in multifamily buildings. And here you can supply a low temperature because of there is a lower volume in the system, so there is no problem with Legionella. And in these two cases, there is no need of circulation pipe, so less heat losses. The second case consider a substation for example, in the basement to interface the district heating system to the building system. In the third case, there is no interface in the basement, so the water coming from the district heating system goes through the building, so it's a downside of this solution. There are many units available in the market. In the last year, many came. Many producers came with a solution for low temperature district heating. The main parameters that should be checked when considered to introduce this kind of solution is the pressure that can be either 10 or 16 bars, usually like normally from the data sheet. The 10 bars is for the single heat exchanger solution, and 16 bars is usually for the two heat exchanger solution. Then what is important in a low temperature district heating system is the supply and return temperature. They are optimized for a low temperature supply, and usually it's between 55 and 65 degrees for the supply side, and the return is around 20-30 degrees. Then there is the power capacity to consider. Usually this substation are implemented in one apartment or one single family house, but they can also supply 2 apartments. Then another parameter to consider is the supply flow coming from the district heating. I'm going through some of the important features of these substations. So basically, what was important in the development was that they were equipped with high efficiency heat exchanger for low temperature supply. Basically, it has been designed to increase the surface for the heat exchange, and so basically supply all the heat possible. Then they allow also to reach a low return temperature, so to optimize the heat supply to the user. They are usually covered with an insulation. They have a cover that covers basically the part that is heated, so all the pipes and the heat exchangers. Some of them, as you can see in the first 2 pictures, some of them are covered basically all the way. So also the valves and the fittings are covered in order to reduce the heat losses. In other cases, like in the top right picture, the fittings and valves are left outside, and so it's important to cover them in a second moment in order to reduce the heat losses. These units usually have the possibility to implement meters in order to measure the heat consumption in each apartment. They come already pre-built, basically, so they are easy to install. They are all the pipes well arranged and divided in district heating supply and then the supply for the building. Some of them, as in the third picture, they have a top and bottom connection, so they are pretty flexible also in existing buildings. They are also adapted with flow control valve, heater load function, so they have a bypass when they are not used in order to reduce the heat losses. Then they have implemented a control system that can be also connected with weather compensation, so they check the weather and the outside temperature in order to optimize the heat consumption. Then they have expansion vessel, as in the fourth picture, and high efficiency pump for the space heating system. They are Legionella safe due to the limited water volume that is in the unit, basically following the German regulation. Now I'm going through what we have done in Østerby. So as my colleague Steen already mentioned, we have a terraced house district with an old district heating network with a lot of peak losses due to renovation of the buildings. So what we implemented was a new low temperature district heating network with supply and return of 55 and 30 degrees with new plastic pipes. So, and we use as heat source, we use the cooling system of the shopping mall that is close by. As my colleague Steen already mentioned, there were different groups inside the district with a lot of different old installation that were not optimized. And so in order to optimize also the network, we had to consider new installation also at the buildings. So what we have done, it was to bring basically the new pipes to the buildings and to optimize in order to reduce the heat losses on the network. And we optimized the length of the pipes inside the house in order to reduce the length inside the house. Then the solution were equipped with the outdoor sensor, as you can see the white wires in the picture. And then we had also implemented an antenna in order to remote control the consumption. In the picture, you can see the circle. The red circle is basically for one family, and the one on the right is the connection for the house next to it. This is the installation inside the house, how it looks. In the circle, you can see the district heating pipes coming inside, and then there is the substation. As you can see, it doesn't require a lot of space. This is in basically below the stairs. It's a small depot, and basically we use the same pipes that were already installed, and we put on the new unit. It was an easy installation since the unit came already pre-built, so we just need to connect the pipes and connect the antenna and the meters. I'll just quickly show also the Swedish side where we implemented the units. In this case, it was a completely new building, so it was easier also to fit them in basically in an installation depot where there is, you can see from the top right picture, you can see also the ventilation and the other installation that are inside the apartment. As you can see, there is also the meter, and here it was implemented with a 3-pipe system. So basically, there are the 2 pipes for delivering the heat plus the cold water installation, basically. So it was well designed, and for all the apartment we used this solution. So to conclude and to sum up, this kind of substation allow a safe transition to low temperature district heating, since they are optimized for low temperature. They can reduce heat losses because we don't use the circulation pipe. They are a complete solution and certified, so it gives like a quality in the district heating connection, because they come already pre-built, so there is no plumber that needs to make improvised solution for each apartment. They are easy, as I said, they are easy to install since they come in a pre-built unit. The heat losses, we checked, and they are around 20 watt in average during normal season, like summer season, while during the heating season they go up to 35 watt. We checked, and the one compared to old installation, you can have also 2 or 3 times lower heat losses. Some comments. So basically the connection, we have to consider that sometimes there are the connection that are outside, like valves, meters, and fittings. So it's important to cover them in order to minimize the heat losses. Then something that could be considered in the future is to give priority to domestic hot water in order to decrease the capacity of the connection, and so use the energy flexibility of the building. So when there is the top of the domestic hot water, just to close down the heat supply to the building for just a period. And then one solution that we considered in Østerby, it was to finance the installation of the unit in the bill. So for a certain period, the user is going to pay the installation, and then that's it. Thank you. I think it was everything. So if you have questions, you can also contact me. This is my email. If you don't have a question now, but in the future.
Yeah, thank you, Emanuele. It was a very technical, interesting presentation. I hope the audience appreciate it, and we are expecting technical questions. So very fast. Let's go to Sarah's presentation, as the time is running out. So please, Sarah, if you want to share your presentation, you're welcome.
Hey, thank you. I hope you can hear me.
Yeah, I can.
You can hear me. That's very good. I'll try to share my screen also. Okay. A bit slow, but
don't worry. Take your time. Just a small remark for the audience. Sarah's presentation concerned the second demo site of COWI, the Lund one, but of course it's analysis on the business model on that demo site. But of course it's very interesting because it can concern different example of low temperature district heating network. So okay, we can see your PowerPoint. Now it disappeared.
You can. Okay, I'll put it in show mode. Now?
Yeah, that's perfect. Thank you. Okay,
that's great. Then it's my turn. Hi, everyone. I'm Sarah. I work as a civil engineer at the energy company Kraftringen, which is an energy company located in the very south of Sweden in a town called Lund, which is actually only a few miles away from Copenhagen. So Kraftringen and the city of Lund, we're part of the COWI project because we are currently building the world's largest LTDH network. And this is a network that will be able to provide heat to a whole new city district called Brunshög, where in the future 40,000 people will live and work. And what you see on this slide is the vision image of that city district. So the size of this network makes it unique. We say that it's the world's largest, but also the heat production is unique because this will be based almost exclusively on surplus heat from one single heat source. And that's heat source is a research facility called Max 4, which you can see on the map here. And yes, we also have max 1, 2, and 3 in the center of Lund, but that's very small laboratories. But this is a really big one, which has been like the whole of Sweden is behind this max 4 facility. And unfortunately, I don't have time to explain how it works, but you can think of it as a big microscope, giving us a lot of excess heat. Now, compared to high temperature district heating, the supply and return temperatures of the network we're building here in Brunnshög are of a level that is more concordant with temperatures of surplus heat from industries like max 4, as well as urban level sources such as supermarkets and data centers. So in other words, LTDH opens up possibilities to increase the use of low-grade heat sources, and you all know that. Now, I will present some thoughts on business models for LTDH divided in 2 parts. One part concerns the price model for buildings that only consume LTDH in this Brunnshög area. And one part concerns buildings that at times deliver heat to the network, like a food store or another building that needs cooling. And a building or a customer that is both an energy consumer and an energy producer is, as you probably all know, called a prosumer, and will be affected by both price models. So here, I will start by telling you about the price model for the LTDH consumers, because that's the part that I also know most about. I've been working with it for a while. But for you to understand the price model of the Swedish site in Brunnshög, you need to understand on what basis this Brunnshög network is built on. So think of it like this. The max 4 heat is, it comes in 3 different temperature levels, but to avoid Legionella bacteria, the customer systems in there, to avoid Legionella bacteria in the customer's systems, then we make sure the supply temperature in our network is 65 degrees. So even though we get lower temperatures, we raise it to 65 degrees. And for the best technical performance of the heat production, we need the return temperature in the network to be around 35 degrees. So these 2 temperatures are the base for the construction of the price tariff for the LTDH consumers. And since the temperatures are so low, relatively speaking, we become able to use a different kind of distribution pipes than normal. The new pipes are made out of plastic, and they're much lighter and easier to handle than traditional pipes that are made out of steel, or the core at least is made out of steel in traditional pipes. But since they're made out of plastic, in this case, it makes the construction of the network easier and cheaper. And that will, of course, affect the price model. And then finally, even though the LTDH system is actually also connected to Kraftlinjen's high temperature district heating network at one point in the area, in this presentation, we consider the LTDH as a solitary system. And since the research activity in the max 4 facility is rather constant during the year, the LTDH heat production is also rather constant. And consequently, the cost for the LTDH heat production is invariant. Okay, so the Brunnshög price tariff for LTDH consumers consists of 3 parts. We have a connection fee, which is based on the floor area of the building that is connected, which is something you probably recognize from other price models. We also have a minimum energy price that the customer always has to pay, as well as a maximum price. But then finally, we have what we base the whole price model on is that we have a return temperature fee. And if the return temperature is lower than 20 degrees, which is very, very good for us, then no no extra fee is required. Then they only pay the minimum energy price. But if the temperature is between 20 and 35 degrees, which is still rather good for the whole system, then there is a level 1 temperature fee per each increasing degree. So for each degree more than 20 degrees that you as a customer deliver to us as an energy company, then you need to pay a little more for each extra temperature. And if the return temperature is between 35 and 55 degrees, then there is a level 2 temperature fee for each increasing degree. And these fees are arranged so that at a return temperature of 35 degrees, which is what we would like to get from our customers, then the total price it becomes of a level that should be easily accepted by the customers, and also just enough to cover the production costs for us and ensure a reasonable payback time for Kraftringen's investments in the production and the plastic pipe network. And at this temperature, where you have 35 degrees in return temperature as a customer, then your total price for the district heating is about 25 or 30% lower than that of Kraftringen's traditional high temperature district heating. So even though some customers get afraid of the increasing return temperature fee, if they have a well-dimensioned system in their house, and we have calculated on this, then they should get a price over the year that is about 25 or 30% lower than had they had the same house in our traditional network. So we hope that it's pretty good. Yeah, oh, I had some features also. Okay, and then there's the detail. The return temperature fee is actually based on not on the actual measured return temperature, but on what we call the volume balanced return temperature. And this is something that is obtained by subtracting the actual transferred heat from the supply temperature. And the transferred heat is obtained by this equation, which is based on monthly averages. And we have, you can see that I have the specific heat capacity for water and a density of water, which is about 1 kilogram per per liter. Well, anyway, this way of balancing means that the economic impact of a typical summer scenario, where you have high return temperatures due to perhaps you have a hot water circulation, it doesn't become very noticeable on the price. And this is something we didn't have from the beginning, but our customers were concerned about this. They were afraid that they would get very high prices during summer, for example, but they won't. So it's been developed with the help of our customers. So to sum up, the connection between the return temperature and energy price should now be simple for the customers to understand. And because it favors low return temperatures, then it also favors well-functioning substations, which in turn favors Kraftringen's heat production, which is very good. That's what we want. And to make the business model more than just a price model, then you could add some soft values. And examples of additional features could therefore be to provide heat exchanger installation instructions to the customers. We could offer help with dimensioning of heat exchangers as well as maintenance. We could perform yearly maintenance visits and also to apply remote reading and control of the substations. And this is what would lift the price model from being just a price model to actually becoming a business model. So now you've learned about the business model for the LTDH consumers in Brunnshag. And before I tell you about the price tariff for the LTDH producers, like the small food stores, for example, I want to repeat some of the general issues about prosumers that that you might know from before. So, for example, if the urban heat sources and the prosumers are numerous, then together they can actually reduce the reliance we have on one single heat source, such as like a combined heat and power plant. And therefore, prosumers are likely to increase the resilience of large district heating systems and be an important part of the district heating future. And at the same time, the district heating company and the prosumer might perceive the quality and value of the heat in different ways. And as such, the relationship between the utility and the prosumer must be carefully defined to ensure fair conditions for both parties. Also, to the prosumer, the necessary investments in, for example, heat pumps and higher electricity demand competes with alternative uses of capital. And that makes it relevant to really think through the risks. And some of the questions to consider are, for example, will the prosumer keep or terminate its core activity, or perhaps will they move its premises? And is the predicted annual heat recovery volumes and use of heat pumps correct in the long and short term? And should the prosumer make all the investments itself, or should the investments perhaps be split between the prosumer and the utility? After all, the profit secured to both the prosumer and the utility. So will the profitability of the investment cause long or short payback periods? Okay, so that was some general issues. And this is my last slide, Gabriele. I will now tell you some of the basic prerequisites or requirements that you can apply to a business model for prosumers that deliver heat to district heating systems. So preferably, the prosumer heat should be of equal quality as the heat coming from the regular production source. So the solution to that can be to set up a requirement of a minimum supply temperature. And in Brunnshag, for example, that temperature will have to be between 65 and 67 degrees. Also, logically, the compensation for the prosumer heat should correlate to the price of the regular heat production that it outcompetes or replaces at any given time. So the solution could be to if the regular heat production is constant, then you offer a fixed compensation for the prosumer heat. And if the regular heat production varies, then you should offer to pay a market price for the prosumer heat. And then also you need to look at what the prosumer heat is actually substituting. Preferably, the prosumer heat should not be supplied when there is no need for it in the district heating system. For example, during summer, like this. You see that during summer there is well, there is not very much need for it. Yeah, well, okay, it wasn't really my last slide, but so what you can do is that in the contract, you can set up an outdoor temperature related prerequisite for accepting or buying the prosumer heat. For example, you could say that the prosumer heat is only accepted when the outdoor temperature is lower than a specific number and or the compensation decreases with increasing outdoor temperature. Or you can say that the prosumer heat is only accepted during certain seasons of the year and the compensation varies with the season. So that was actually it. That was my last slide. Yeah, thank you. Are you there, Gabriele?
Yeah, I'm here. Thank you, Sarah. Thank you, Sarah. Okay, so we should run out. We should have run out the time, but we have some questions. So I ask the audience to be patient for 10 minutes more. And I ask also Emanuele, okay, to switch on the webcam, great. So we have, I will select a few questions, and for those who for the question who has not been replied, you can follow up by mail. So the first question concern Østerby. Could you precise how you calculate the heat losses from which energy to which delivery point? I don't know if Emanuele, you can reply that.
Yes, I think it was in basically from a substation, then a part of the main line, and then the distribution network inside the district, basically. And since there were like super old pipes and with humidity in the insulation, they resulted to be pretty high.
Okay. Okay, thank you, Emanuele.
So basically it was from a substation to the final user.
Okay, great. Thank you, Emanuele. A question for Sara.
Yeah.
Connection fee for Lund consumers.
Yeah.
Is it one-off fee for connection, or it is a regular fee, for example, monthly, for having access to the DH system? You know that, or?
Yes, I think it's you pay once, like you pay for the connection fee, or you pay for the connection, and that should cover the construction of the actual pipe system for that, well, for that customer. Yeah, that should be like for a one-time connection fee, and then you only have your energy price, which is based on the return temperature.
Okay, thank you. Second question for Emanuele. In the Høje-Taastrup case, which was the temperature supply on the secondary side for heating before and after the implementation of the LTDH?
So before, the supply was 85 degrees, and now we're going to supply 55 degrees to the user.
Okay. Okay.
And that's actually very interesting, because we have different levels in Sweden and Denmark for when we think that there is risk for Legionella. So in Sweden, we've chosen 65 degrees, but you have 55 degrees. And that's not because we have different bacteria, but because we only consider them differently on national level.
It's basically a regulation, yeah, exactly.
Mm.
Yeah, I'd like a lot of question, regulation, policy, as you can imagine, but we don't have time. But yeah, thank you, Sara, for remarking that. A question for you, Sara. When estimating heat quantity and return temperature, do they consider house level or apartment level consumption?
We consider house level consumption. Is the simple question. So we look at during a month, what was the average return temperature from the access point to the house, which is only one, even though you might have 150 apartments in the house.
Okay, great. Emanuele, I cannot see you anymore. I don't know if you are there. Okay. Important that you are here. I can hear you, but I cannot see. Okay, you are here. Don't worry. So, I think a very simple question for you, Emanuele. Was there in Østerby area, was there any multi-apartment buildings, for example, 10 or 20? I don't know. In the question is written stories. I don't think it's. I think a typo. Which was covered by the LTDH system. So
no, it's basically just single family houses with 2 floors. And there was no multi-apartment buildings, basically. The only one is in Lund, but it's like 5, 6 floors, I think I remember. Do you know, Sarah, maybe? Exploring how many floors?
5, I think. 5.
Yeah,
I think there's 5.
Like
I've been up on the 5th floor, so I think that was the highest one.
Yeah,
But in Brunswick, that's in
it's not
Brunswick.
like
And in Brunswick, we almost only have multifamily houses. So the Danish,
like in Denmark,
Sweden, it's very different.
Also in Denmark, there aren't so many like tall buildings. So yeah, that's it.
Okay. We have two questions for Sarah, but the question it's actually three questions. So okay, I will select few points of the question. Is there any cost analysis we can refer for that? It's open for public. I think you can access the repo on the COWI website, right?
Yeah, but it's not very. It's not a public report actually, because it contains a lot of numbers that are like corporate secret. So no, unfortunately not. And the second question was, what will the pros and cons of prosumers do? Yeah, the question is, what will they do to lower the return temperature? Well, basically you can have, if you can avoid having a hot water circulation, then that's good, because hot water circulation gives higher return temperatures. And one way to avoid having hot water circulation is to have flat stations, like Emanuele presented. But that costs quite a lot to have flat stations, so many of them. So we have had customers that they become worried, like, but how much will it affect me if I keep my hot water circulation? And the answer is that it actually doesn't affect very much. So our recommendation is not to avoid it. So you can have hot water circulation, but make sure that you dimension your radiators, for example, and like keep it well maintained, and then you should be fine actually. I have some slides about this for people who are able to stay, but that's up to you, Gabriele. Perhaps we should take some other questions before I do that.
Yeah, maybe it's better to take one last question, because we need to keep the web. But of course, for the audience, if you want to contact, I think Sarah is okay, or you can also write your question on LinkedIn under the event post. So maybe I can forward the question to Sarah afterwards. So I think this question could be applied to both of you, but maybe I address the question to Emanuele. Are you using automated network design planning tools for the district heating network? Are you using automated? Okay.
Sorry, I couldn't hear. There are some problem with the...
Okay, I can repeat. Are you using automated network design planning tools for the district heating network I think in Østerby?
So what programs do you use?
Okay. Yeah, okay. We used in our design of the network, we use Thermis to dimension the network and to see the heat losses and all the supply features of the network, basically. But I'm not really into the network design actually, so I cannot answer everything.
Okay, don't worry. Okay,
that's it. I mean, we use Thermis for sure.
Okay, thank you. The very last question for Sarah. The question number 8. I don't know if you can read it. It's a very long question. Is it if the Lund demo case is a greenfield project? In that case, it's easier to design the low temperature domestic water adapter to buildings and to implement low temperature radiators or system into the buildings. In case of brownfield project, I suppose it should be more complicated to be implemented. I don't know if the question is clear.
Yeah, I think it's clear. The question, what you're saying is that Yes, because Bunsag is being built right now from the start. There's only field today, so we have the opportunity to make everything right from the beginning. And also, we've chosen to build this low temperature district heating network because it's well adapted to new buildings. Normally, when you build a big area with very well isolated buildings, then it can be hard for the district heating company to actually get out the payback that we need from all the investments. So this is a way for us to be able to actually deliver district heating to this area, even though it is an area with very low consuming houses. So if you would want to implement low temperature district heating in an area with existing buildings like they're doing in Denmark, like Emanuele is doing, then it might be harder because those houses might not be as well adapted to the lower temperatures. With that said, we have, like in Lund, we are not only building completely new districts, but we also have places inside the existing city that they want to, what's it called, förtäta, also when you build more houses between existing houses, that is. And we're talking about how to be able to provide low temperature heat to them, because that's in the middle of our high temperature network. But then we're talking about perhaps we can deliver low temperature heating to them from our return pipes in the high temperature network. But we haven't done it yet, but that might be something to explore.
Okay.
So.
Thank you. So I think we can conclude here the webinar. We exceed 15 minutes, but it's fine. You know, it was a very interesting, I think, webinar. COWI, it's really innovative. So I'm also very glad to share with all the DSC community the results and the achievement of COWI. So stay tuned, because we're gonna organize other webinars in the coming month, hoping that we will be organizing a physical event finally. So in the meanwhile, stay safe and follow COWI on the website. And thank you for having followed the webinar so far. Thank you, Sara. Thank you, Emanuele, and thank you, Stan. He had to leave us before. And see you soon. Thank you, everyone.